And these are the type of tests that are conducted, and they're the strict test conditions. And the result then to where does this particular port want to site an LNG, or the LNG bunkering operation is going to take place in a particular area. So the study is, how will the vapor cloud surrounding area, can we conduct this operation safely? And if we can do it safely, what would happen if we have a spill? And the results of this are documented in the emergency procedures manual, so all parties know exactly what's going in the event of a resultant vapor cloud. An example, as you see, it's there doesn't appear to be too much wind in this particular. I did have some pictures which for some reason didn't get into the presentation, but that's true. I would suggest that the source of the spill is the pressure, and there's wind blowing in this direction, and then the vapor cloud heads out in this direction. Seeing it's fairly uniform in size, but if we look at the cloud, this isn't a true indicator. As we look at the outer limits of the cloud, this is going to be on into that 5 area. The concentration inside the cloud itself, the condensation of water vapor air, it's the area that's probably too rich, and ignition is not going to take place in this area. But as we get out to the outer, that water vapor cloud, this is where we start seeing, in this area here, right near the top, up in the range of that 15%. And then as you work away from that, it's going to go down to the area. So this is the area that we're concerned about reaching with. And if you're looking at the test, you can see that it's done in an area where there isn't around. This particular one, I'm not sure, Exponent, that's a company that does does a lot of testing, and their laboratory, this looks like might be in some type of a remote desert area. So these tests are done in areas very controlled conditions. Emergency response for facilities are determined by the terminal location. So there's a general set of principles or rules that we can basically apply to all terminals. But every terminal is going to be unique in its characteristics, and as a consequence of those characteristics, we will see different plans for different terminal locations. The size and the type of the storage area is also of great importance. We might be talking a terminal area where perhaps we have a small LNG tank that contains, let's say it contains 1,000 cubic meters of LNG. The consequences or the size of that tank it's a relatively small tank, so it's the impact if there's an incident obviously wouldn't be as great as, say, if you had a tank with a capacity of 50,000 cubic. So we look at the size and type of the storage area. We're going to look at type and size of vessel service. This will have an impact on the storage area, obviously. If we're looking at a facility where we are servicing small offshore vessels or personal service vessels with a small capacity, small fuel capacity, 56 cubic meters, it would definitely be different than a facility that is going to be seeing large container ships, large passenger ships, where the fuel capacity might be in thousands of cubic. And the size and type of the products that are processed. Most important in function emergency procedures is we always want to keep foremost in our minds the protection of property and the protection of lives. We want to reduce the likelihood of equipment and product damage. We try to take into account every possible emergency that one could imagine. I don't have readily at hand an emergency procedures manual, but these are usually documents that are very, very thick. They not only outline the procedures that are carried out, but they go down into the detail to do what, who is responsible for what. And this plan, the Emergency Procedures Manual, is usually developed with the aid of local fire services, your local emergency services, your local hospital services, your emergency management systems. All of these parties take part in putting together these emergency procedure manuals so that you have input from all the various agencies. Everybody's perspective of an emergency is going to be a little bit different. The response of the fire people is going to be different than the response of law enforcement people. Let's say, for instance, it's going to be different than the response from people who staff medical facilities, the people who are personnel on ambulances and things of that nature. So everyone has a different perspective and has something to offer, and their input is critical when we put together one of these emergency procedure manuals. Fire management ashore, fire management ship. Basically, it's the end result is the same. We want to minimize damage. We want to protect property. We want to protect lives. Equipment and strategies employed vary with the type of fire. Fire is fire. I mean, this is something that I try always to bear in mind when I'm thinking about this. We reference here a minor fire. Fires may broadly be categorized as minor fires at pump glands, pipe flanges. Minor is a relative term, if you will. I mentioned this the other day, I was involved, I was on board a ship where we had this fire at 1:30 in the morning, and it was a vacuum pump. The bearing of a vacuum pump seized up, and the paint on the bearing casing caught on fire. The grease inside the bearing caught on fire, and this is considered a minor fire. But in actuality, when we're dealing with a flammable liquid such as LNG, and we're dealing with the potential in vapor and whatnot, there really is no such thing as a minor fire. Any fire has the potential of major consequences and can be disastrous. So fire is a fire, regardless of where it is, whatever its origin. The idea is we want to get this under control and extinguished as quickly as we possibly can. We have the fires from the confined liquid pool, and we covered those. We also can see fires from unconfined spills. Terminals are designed where they have impoundment areas at any place where a leak can occur. Most of your piping on a terminal location is welded. We try to minimize the amount of flange connections because anytime you have a flange connection, you have the possibility of a leak or a gas failure or something like that. So we do try to minimize that by having all of our connections welded. But if we do have a flange connection, you're going to find that there are impoundment areas that are designed into the facility to contain any type of a spill. We don't want an unconfined spill, and because an unconfined spill creates a situation that's more difficult to control. Then we have fire in confined spaces. that's in a compressor room, inside a building, inside an engine space, inside an accommodation area, inside the galley of a ship. These are the places that are confined, and we have to have plans on how we're going to deal with a fire when we are confronted with one of these spaces. The guiding principles, make note of this please, your guiding principles for fire control, first and foremost, is an effective attack. You have to have a plan. This is why we develop these procedure manuals. This is why we develop these. We have a fire in the compressor. How are we going to attack? What are we going to do? This is when personnel respond to a fire, they assess the situation. What is it that we have here? What are we confronted with? And then there is, in almost every case, there's going to be a pre-planning. This is what we're going to do when we're confronted with the fire in this particular area. And you carry out this plan as quickly as possible, as you possibly. Part of that effective attack or the guiding principle is, what are we going to do if it's a fire as a consequence of a spill? One of the first things that we're going to try to do, in addition to keeping the fire under control, is to secure the source of the spill. So if you stop the source, you stop the spill, you remove the fuel, or eventually that fuel is going to be depleted. We want to protect the surroundings. And this is where the water deluge system comes in. This is where water spray systems and anything that potentially could catch on fire and is exposed to radiating heat from a fire. You want to keep those things as cool as you possibly can. So you may have a contingent that's actually attacking the fire and fighting the fire, and you may have another contingent group of people. Their duty is going to be to protect the surrounding property, also protect the people who are attacking the fire. We mentioned in the fire section where there may be a team of people who are going to continuously use water spray on the people who are actually attacking the fire to keep them protected, to keep them cool. Another way to attack a fire after we assessed it is to allow the fire itself to burn out. And you just control the area around it and make sure that there's no damage done to personnel and property in the surrounding area. So sometimes the solution is, okay, just let this burn out. There was a recent case here I just saw in our local newspaper where an individual punctured a fairly large propane tank, which resulted in a jet fire. And when the fire department arrived on the scene, they decided the best way to do this is just have a controlled fire and let the fire burn itself out. So they applied water to the outside of this propane tank to keep it cool, so that they weren't confronted with the potential of one of these levee incidents. And the fire eventually, when the fuel was dissipated, the fire went out, and that was the end of it. The various fire control systems that we're going to find in a terminal. Again, this is more review than anything else. We're going to see water. We're going to see water deluge system. We're going to see in this particular graphic here. You see here's a firefighter who is holding a water hose with a spray nozzle on the end of it, and he or she is probably either using that spray to protect personnel who are advancing the fire, attacking the fire, or very well may be using that to cool down areas around the fire to keep them from, to protect them from starting on fire themselves, keep the fire from spreading. Dry chemical powder systems are strategically located throughout the facility, throughout the terminal. They're also strategically located on board the ship. Once again, every area on the weather deck of a ship, the exposed decking of the ship, has to be able to be reached by a dry chemical hose. So there are numerous stations throughout the ship and numerous stations throughout the terminal. And the dry chemical supply is usually very, very large. Uh, if there is a fire and it's going to be attacked, then dry chemical is going to be the extinguishing agent of choice. Uh, you want to use the largest amount of dry chemical that you possibly can. Uh, we're not shy. Once again, we're not shy when we attack a fire. You want to go in, you want to hit it hard, you want to hit it fast, you want to get it out. Uh, Carbon dioxide was mentioned. This is not so common in terminals. It is an extinguishing agent that's used on ships. There's also vaporizing liquids such as halon. Halon was a very, very good product. Unfortunately, not environmentally friendly and is no longer used on new construction or new buildings because of its environmentally damaging potential. But halon is a product. When we were talking about the 3 things necessary for a fire, it's now taught when we go to these firefighting academies, firefighting schools. There's actually 4 things that are required, or there are 4 things that you can use to extinguish fire. You can remove the fuel, you can remove the oxygen, or you can source of ignition. Remove any one of these 3 things you're going to extinguish fire. The 4th one is the products such as halon, and there's other products on the market. What these products actually do is they disrupt the chemical reaction that takes place when you have a fire. So by interrupting that chemical reaction, even though you have air, even though you have fuel, and even though you have the ignition source or the flame, the fire will extinguish because the actual chemical reaction has been interrupted. Very good agents, but they're less commonly found on board ship and in terminal operations now. Emergency procedure prerequisites, firefighting plan, muster lists, these things prominently displayed and used and understood, read and understood by all personnel. If there is a fire, people are going to go to a pre-designated spot. One of the first things that is done when we have a fire scenario is you account for your personnel. It's primary, of the utmost importance that we know that all of our people are safe. So if we have one of these mustering locations or gathering points, if there is a fire, we go to these locations first off, and we make sure that all of our personnel are accounted for, and then we implement our firefighting plan in the firefighting procedures manual or in the emergency procedures manual. Sometimes these documents are combined documents, sometimes they're separate documents. But the essential thing is that we account for our personnel, and then we proceed with the plan to extinguish the fire. It's absolutely essential that all of our personnel on board ship as well as in the terminal read and understand these manuals. They have training. We have training sessions on these things where the manuals are reviewed on a regular basis on board ship, and I believe terminals are also doing the same thing. It's all part of the emergency management plan for the facility. Firefighting and emergency drills are going to be conducted regularly. Like I said, on ship drills, terminals might not have them frequently, but they do have drills on a regularly scheduled basis. They have joint drills conducted regularly by agencies. We have joint drills with a vessel. The vessel is at a terminal. Sometimes a vessel will go in and it's been agreed upon that there will be a joint drill between the vessel and the terminal at the same time. It's a pre-planned thing where the vessel's aware of what the emergency is going to be. But we have the drill, we respond to it. This way, we're always ready to work in conjunction with our opposite party, be it the terminal, be it the ship, whatever the case may be. Firefighting procedures to follow, and this is going to be common for any type of fire. First of all, raise the alarm. You let somebody, we have a fire. We muster our people, assess the fire source extent, personnel at risk. This is the important thing. Again, that mustering point, that gathering, make sure our person, once we've determined personnel is safe, whatever it is we have to do. The emergency, we implement our emergency plan, our fire plan. We stop the spread of the fire by isolating the source of fuel if at all purposes, cool surrounding surfaces under radiation, uh, and uh, and this is basically the plan that's going to be used almost with any type of fire, be it on board the ship, be it within the confines of attacking the fire. We're going to use the appropriate agent, again with an LNG fire, a vapor fire. The agent of source or the agent of choice is going to be most likely dry chemicals, the most effective, and it's the easiest and best. If it's not possible to extinguish the fire, we're going to control the spread of the fire. This is, I'm going to review this again, again, and again as we go along. If you can't put it out, you want to control the spread, and this can be done from the outside area. Again, this is one of those scenarios is if the firefighting people decide the safest way to fight this fire is just to let it burn out, and they'll just control the outer areas, keeping the outer areas and outer personnel in the outer areas safe. Let the fire extinguish itself by going through its fuel source. Water deluge systems, again, these are fixed storage systems that we're going to find on storage tanks, jetties, the various plant assets, buildings throughout the plant. They're on the loading manifolds of the ship, on the tank tops, all of the tank piping on board the ship is protected by a water deluge system. And this system is designed to provide a layer of water that's going to cover exposed surfaces in the event of a fire, in the event of a spill, so that we can control vapor, and it's used for its useful cooling effect. Application rates vary with the distance of the structure to be directed towards the fire. You put as much water out as you possibly can. But I guess the rule of thumb is 2 to 10 or more liters per square meter of protected surface, the minimum requirement, depending upon the type of area that's going to be protected. Hopefully, in most cases, they exceed those minimums. You never want to have something that just operates at the minimum. You want to have something that's going to exceed that by a fairly large amount, because once you put a water system under pressure and water starts to be dispensed from that system, you're going to get a pressure drop. And when you get a pressure drop, the volume of water that is going to be dispersed is going to be overall less. So you want to have high capacity pumps. The water deluge pumps on ships are very, very, very large capacity, so that when you put this system on, you have a considerable amount of water coming out from all of your distribution points. These are usually some type of spray nozzle, and water comes out in spray. Water spray from fixed monitors and handheld hoses is another means that we use when we're using water deluge, and they can provide radiation protection of personnel in their approach as they advance the fire, or as they advance the shut-off valves to secure the source of fuel to a fire. Special application of water spray from hoses is to deflect an unignited vapor cloud away from the ignition source. Viewed that earlier, and once again, you can use water spray to direct the way a vapor cloud is going. And if you see it's approaching an area, perhaps a known ignition source, we actually can control vapor by using water spray from the cargo flaring cargo ashore. When you're flaring cargo, you're controlling. It's a vapor release, controlling vapor. So as we've already talked about, the amount of flaring that's done now in terminals is greatly reduced over the years. When I first started sailing and the ships went into a load port, the uh, the vapor generated and the vapor that was coming out of the cargo tanks, liquid loaded into these tanks, uh, it went simply to a flare and it flared off. In the early years of the LNG trade, this this boil off or vapor return was seen to have no value, and we were not as environmentally aware then as we are today. We're talking 35, 40 years ago. Uh, as we begin to better understand the environment, better understand what greenhouse gases are, and knowing that LNG or gaseous natural gas methane is not an really an environmentally friendly product in its natural state, greenhouse gas. Uh, it was seen that we have to reduce this. And also, as technology advanced, uh, people began to see there is an economic value to this boil-off gas, and the boil-off gas was seen as a valuable product that can be used as something at the loading terminals. Uh, the boil-off gas is usually returned into the facility and is used as feed gas for gas turbines to generate electricity, or in some cases, it's actually put into a reliquefaction process where it's reliquefied and put back into the tanks. So today we see much, much less flaring, talking liquefied natural gas. As far as refineries are concerned, we still see a considerable amount, but even refineries today are seeing economic value products. They're under environmental pressures to reduce the amount of flaring, seeing less and less. Vapor is returned to shore from the loading vessel. When the vessel is discharging, boil off or return gas is an issue because as tanks on board a ship are being emptied, we receive vapor from shore tanks. So it's a closed operation doing a vessel discharge. Uh, but in any case, regardless if it's a loading terminal or a discharge terminal, flares are still available for emergency use. There's always going to be a means if pressures for some reason do get out of control. Uh, you have to have a means to leave pressure, oftentimes, so that means flaring device. Your vent riser fire control. Why are you going to have a fire at a vent? Uh, First of all, you have to have some type of vapor passing through that vent riser or to that gas. In some cases, and this has happened on ships, you have a scenario where perhaps leaf valve on a cargo tank doesn't happen with great frequency, but it does happen. Uh, that's the case, and a small amount of vapor pass through a relief valve. It has to have some place to go, and it's going to go to a vent riser. A vent riser is a vertical pipe that comes from the vapor side of the shipboard piping, and it raises it. It's higher than the accommodation area of the house on the ship, and what this does is it gives you the means if you have to vent any product into the environment, it's released at a height that's higher than any potential ignition source on board the ship. And so this is the purpose of a riser. So if you have a relief valve that's leaking, you would vent that to a place higher than any potential ignition source, and it's by the time it reaches the exit point of that riser, it's at such a temperature that it immediately rises vertically and is going to be out of the way. Also, if you have to have controlled venting, a condition that does happen on rare occasions, but a vessel can be subjected to higher than normal tank pressures, for instance, if it's endured heavy seas and heavy rolling and pitching of the vessel, where tank pressures might be reach a point where they can't simply be controlled. All right. Okay, I'm just about done. I think there was only a couple of more slides on this to wrap up. If possible, secure the float to the vent riser to extinguish the fire. That's oftentimes the easiest way to do it. And if that can't be done, you can use water spray to keep the vent. If you have a vent mass fire, the most likely ignition source is going to be lightning. I indicated to you earlier one of the experiences I had where we had a vent mass fire controlled, and it resulted result of either lightning or an electrostatic arc, either one. Doesn't make any difference. We had that source of ignition, and we did have a vent fire. You can also inject nitrogen into the vent mass, and that'll the fire will be extinguished. The air has been diluted to such a point where the fire can't be supported. We're always going to continue to cool after a fire is extinguished to avoid possible ignition. And if we do have a vent mass fire, when safe, it's going to be inspected. So emergency procedures, we have to have these emergency procedures for just about every possible contingency for multiple reasons. You all must understand how things can happen, why they happen, and what needs to be done when we do have a situation. Emergency response has to be methodically close supervision, and according to the plan. That's the purpose of the whole thing. Having a plan, and if we have a plan and it's implemented the way the plan is laid out, usually the results are very, very positive. All right, Jared, 1:30. Or actually, you want to do, or how about one? You want to go a little bit? Okay. All right, 1:30, and we'll probably have this wrapped up a little bit early, so I think 1:30 will work out. See you then.